Okay. And there is only one equation from the equilibrium, and two equations from the equilibrium, one in due to summation in vertical direction and another one due to moment. So we can't solve it. So here we take advantage of symmetry. If both spans are equal, okay, we can do that. Otherwise, we have to, if both spans are not equal, then what we have to do? We have to use compatibility.
What compatibility?
Compatibility here. I will give you an example of that also. When you have unequal spans, then how to solve it? In that case, you will require compatibility. You have to use compatibility.
In a symmetry case, if I take a moment here, it will form couple, it will generate two generates. But it doesn't mean that this answer is zero.
If both these forces are equal and opposite, then it will be zero. Okay, so we are keeping these forces equal and opposite using symmetry. If it is symmetric, so this force will be equal to this force.
Okay, to counter this moment.
To counter whatever moment, if it is symmetric. Okay, if this structure is symmetric, then this force has to be equal to this force. Symmetric or anti-symmetric. If this structure is anti-symmetric, it's not really symmetric, it is anti-symmetric.
Symmetric in case of, it is not symmetric in case of loading, because it is
not in case of
loading.
Why not?
Because like cut here, mirror image not be same like this.
Okay, the question is whether this assembly is anti-symmetric or not. What do you think? For anti-symmetry, what was the condition? You plot the deformation, how it is going to deform. Okay, you can consider this in the whole building also. And if you calculate V, it will be BQ, this will be 5Q, and this will be. So suppose I am considering this. Okay, then V will be equal to how much? 5. And then this is Q. Now, if you look into the number of unknowns in the vertical direction, 3 equations or 3 reactions are there. Okay. And the equations we have is, one is summation of all the forces in y direction equal to 0 we can use. And let's say this is also, but here let's take this also unknown. So one is you can say summation fy equal to 0, another you can say summation fx equal to 0, these are our equilibrium equations, and summation m about any point has to be 0. These 3 equations we can use. Now summation fx equal to 0 will simply give that this will be equal to 6. Okay, there is no other horizontal force. So this will give us that this is 6. We got it. Now, how can I solve now vertical reactions? I can't solve using equilibrium alone. Okay, I have to use compatibility. And I know from the deformed shape how it is going to deform. If you look here, what is the shape? Is it symmetric about vertical axis? No, it is anti-symmetric. And in anti-symmetric, these equations will be equal and opposite. So if this is R, this will also be R. Provided both the spans are equal, both the beams have same stiffness. If the beams are of unequal length or unequal stiffness, then I can't use anti-symmetry. So using anti-symmetry, I have used this R and this also R. And if it is so, then this will become 0.
Sir, how will be answer? How will it be anti-symmetric? The force above is
You
5Q.
put a mirror here.
But the force acting on above is 5Q and below is 6Q.
Yes. So if it is a mirror here, how does that matter? Is it more on left? How you say? Above is 5Q, bottom is 6Q, but what is on left and what is on right? These forces are acting on both, left as well as right. We are not considering anti-symmetry about horizontal plane. I am not putting my mirror here. I am putting my mirror here.
So on this side also Q should be there.
You agree or you do not agree? Neither does not agree, I know that. But do you agree or you do not agree? Others. Because if you agree, you have to agree with it. Yes.
The bottom column, the deformation would be due to the 6Q
Right.
force, and the top
It will be 5Q. So if the column stiffnesses are same, the deformation and top and bottom is going to be less. Okay. But that we are not considering. We are considering about horizontal axis, vertical plane. I am not saying that this force is equal to this, equal and opposite this force. I am saying this force is equal and opposite this force. Okay. If you are not convinced, let us say, so you can use compatibility. Let us say this is EIB, this is EIB, this is EIC, this is EIC. Okay. So let's say we don't want to use anti-symmetry. We are not sure. What else you can do for analyzing a indeterminate structure? You have to use compatibility. Okay. So let us say it is rotating like this under. I am not shifting it. Okay. I have kept it here itself. So this displacement I will come later. Let's say it is this. So what is the compatibility condition? Compatibility condition is that this rotation here has to be same. This is the compatibility. That this rotation on the left side and right side should be same. So this angle theta here has to be same as theta here, irrespective of whatever loads are acting. This compatibility condition is to be satisfied. Now, if this is theta, how much will be this? Theta into L by 2, and this will also be theta into L by 2. Now, this reaction R has to be such that this displacement should be equal to theta by 2. So R into L by 2 whole cube divided by 3EIB. Let me say that these R are different. This is R1, this is R2. So R2 into L by 2 whole cube over 3EIB is equal to theta L by 2. Agree? And that is also equal to R1 into L by 2 whole cube over 3EIB. Isn't it? So from here we will get that so R1 and R2 are equal and opposite. It is coming from compatibility. Okay. Suppose the spans were different. Even if it is Q, let us say, even if there is no force acting, if a force is acting here, then also it will be similar situation. But suppose this is the situation, and this is EIB, this is EIB. But let us say this is L, rather this is 2L, this is L, and this is H by 2. Or let us say this is L by 2 and this is L. So this span was 2L. This was 6 meter, this was 3 meter. Let us say. Now
in theta will be same. Or
Now also it is going to deform like this. Sorry. Will R1 and R2 equal now also?
no.
R1 and R2 will not be equal now. Okay? And hence there will be a force here also. So to solve this, you need three conditions. What will be the three conditions? Summation F5 equal to, of course, before that summation Fx equal to 0, that will give you that this is Q. Summation Fy equal to 0, summation M about any point equal to 0, and compatibility. Can you use these three equations and tell me R1, R2 and R3? Like we have done in the previous case. So these are the three basic principles which every structure which is linear, non-linear, okay, static, dynamic, these three principles it has to follow. What are those? Equilibrium, compatibility, and constitutive law. What are the different constitutive laws which you have studied so far? Stress-strain relationship, and phi, and theta, q theta. So it has to follow these, and all these are basically stress-strain. These are coming from material. Okay, stress-strain curve we have represented in different forms, because however m phi is obtained from stress-strain curve and considering the geometry. Okay, so basically it is material constitutive law, stress-strain relationship of the material. Yes.
Sir, in this uniform profile, the level should be defined.
Right.
So it should be matched either above here or below. But compatibility
No, this point can't move up or down because it is supported here. So this point can't move up or down. So let me use a different curve. So we are considering a small deformation. A small deformation means that the deformed length and the original length is more or less same. So this point can't move. This will remain at the same level. The rotation will be such that the compatibility at the joint is satisfied. That means this angle will be same. If it is theta here, theta here. Okay, now you calculate it. This displacement, this displacement. Okay, both stiffnesses are same, lengths are different. So you will get a relationship between R1 and R2. Let's see what relationship
Here,
here.
if you the column is rigid, in that case, that is the different.
Why?
Because
You draw the deformation. You think left and right angle will be different?
No, angle will be similar because the compatibility.
Yes.
It will be 90 degrees.
Right. What will be different?
Delta will be different.
Delta is different. That I have also. Delta is going to be different. Here the delta is going to be theta L by 2 and here it is going to be theta L. So delta is different. Theta is same.
So R2 equal to 8 times of R1.
R 9 times.
8 times.
Which one is higher? R1 or R2?
R2.
R2 is higher? Can you look at the physics and understand? One cantilever is small, another cantilever is large. Okay,
R1 is bigger.
but both have to be given by same rotation. What will happen? If load P is there, what is the displacement? Pi cube over Pi? What is the rotation? Rotation is you simply divide it by L. So it will become Pi square by 3i. If Ei is same, okay, L is double. So for the same rotation, what will happen to P? No, theta and I want R1 in terms of R2. Yes? 4 times. It's very simple. R1 will be 4 times of R2 because the displacement is proportional to L cube or the rotation is same is proportional to L square. So if length doubles, force will be reduced to 1/4 to cause same rotation, same chord rotation. So once you get this equation, now you have 3 equations between R1, R2, R3. Now you can solve it. R1 will be 8 R2 if displacement was same. Displacement is not same. It is theta.
So for theta and displacement, reaction should be R2.
So R1 into L by 2 whole cube over 3EI is equal to theta L by 2. Okay, and R2 into L cube over 3EI, that is equal to theta L. So if you just double it, okay, so this is theta L by 2, that is theta L. So 2 times R1 L by 2 whole cube over 3EI, that is equal to R2 L cube over 3EI. Agreed? Sorry, L square, not cube. No, L cube. We have L cube, we have equated displacement now. Okay. Okay, so 3i, let's cancel with 3i, L, L, so 2 R1 by 8, okay, is equal to R. So R1 is equal to 4. Okay, Anu?
Yes.
Got where you made mistake? So now can you solve it?
Yes.
So please plot Q delta curve for this. Let's consider the stiffness of column EIC, and let's assume that the beam is yielding, and here this is same MVy here, MVy here. Yes. Okay. Please do that. Now you know the relationship between R1 and R2. You can solve R1, R2, R3. Do that. Once you know R1, R2, R3 in terms of Q. Okay. You plot Q versus delta. Calculate delta. You can calculate rotation. Then knowing rotation, you can calculate delta V and delta C. So let's do that. The procedure will be same as we have done for all other cases in the past. So you have not yet told me whether you want to submit tutorial number 2 or not. You want to submit. That's clear. Okay. When? You decide. Monday? Coming Monday? What's the date? 27. Okay. So 27th is fine with everybody? Good. So 27th is the date. 27, 5:30.
We have to find Q delta relationship at the top of the
Right. Right. This is delta. So Q versus this delta. And this delta, as we have done earlier, this will be delta B plus delta C. So calculate delta B and delta C. Huh?
Demand and
So exam will be open. Exam will be open.
Exam will be open, don't worry. But still, you will not be able to do it. So practice. You will not be able to do it means if you do not practice. If you are depending on the open book तो होगा देख के कर देंगे कुछ. And keep in mind, open book means the evaluation will be tough. You won't get for copying something from the notes. You won't get marks. If you have correctly interpreted what is there in the notes to that question, then only you will get marks. So, do you want open book or closed book? Closed book. Okay, so you have decided to keep it closed.
Close book, but we should take the formulas, like Mendel's formula.
Which formula?
Mendel's formula.
हाँ वो सब मिलेगा, don't worry. Mendel's formula you will get.
And sir,
You need not to remember formula. Don't worry.
so
Even if it is closed book. But don't ask me to give this formula for theta, okay? That will not be given. Mendel's formula or that we have in that low cycle fatigue, those formula will be given. So has anybody calculated delta V? Huh? QL square अच्छा Q H square L A T I V 18 9 check करो 9 and delta C now tell me Q1 you are able to get those? Yeah, try yourself now. 1.3,
1.5
1.5
MB by
H. And where the yielding is occurred. Earlier it occurred in both the beams simultaneously. Is it occurring simultaneously? Shorter. So this time the yielding will occur in the shorter. So everybody please come up to this point, then we will move forward.
But the nature of movement in both the beams are different.
Nature of okay, clock, I mean horizon, horizon direction. Yeah.
So if taking motor section is not
Symmetric.
MB by 4 for the
So in real beam, if it is RCC beam, let us say, at the top the reinforcement will be more, at the bottom reinforcement will be less. So even though the left beam is having longer length, but the right beam in that case also the right beam is going to fail because tension will also be bottom and the moment is also more. Here for the simplicity we have assumed that the moment in fogging and sacking is safe. So exam schedule you have already got. Our exam is okay. Don't worry, it will be only when it is. Okay. So you know on first and second we are going on a study tour. How do you feel? Don't worry, we will also go. So in May, once your exams are finished, then we will take second tour. That will be for first year. It should be. It should be. It should be. We are doing Himalayas only. It will be the same project. Okay, maybe the tunnels and bridge may be different, but it will be to the same project. So we will have a second tour for the same project. So the hinge forms here. Now you can see that even if hinge forms here, it has not become a mechanism. Still, it can take more force. Okay.
So can you go on the result slide?
Okay. Delta y will be submit this value of Q there. Okay. So it will be 1.5 mby H over E L over 9IB H over 12IC. So here my curve will not become flat from here. Still, it can take more. Let me call it this as QY1, this as QY2. You mean why we are calling them QY1, QY2? We can call anything.
Y1 and QY.
Because when first hinge formed, okay, the structure has not yielded fully. So then second hinge will form. Then it will yield fully. So there are two hinges forming. Okay, and the stiffness is changing as soon as one hinge forms. So when the first hinge forms, the stiffness reduces, but it does not become zero.
So this QY1, where the first hinge has formed, in this structure,
The structure,
in the structure where the first hinge has formed, QY1.
first hinge has formed when this force is equal to this much, and the hinge is forming here. How you will know where the first hinge will form?
Demand to capacity.
So calculate demand to capacity ratio. Check whether, if suppose the DCR at this location and this location is same, then both the hinges will form simultaneously. If it is not same, then where the hinge will form? Where the DCR is higher.
But sir, in this case, at this location, this location, it is 0.66. This side.
What is 0.66?
DCR ratio.
Okay.
And this side it is 0.33. So
Where?
first hinge is from here.
Where 0.66 is? Where the DCR is 0.66. Huh?
This side.
Huh.
And this side it is 0.33.
Huh.
So second hinge has to come here.
Right. Because columns we have designed stronger than the beam. So column hinge is not forming. Beams will form in, hinges will form in columns.
Okay. Then again I have to apply further to get hinge here.
Right.
That is QY2.
Right.
That is
Right. QY2 will be sum of QY1 plus additional force you will do. So you will follow the same procedure. First you will calculate the DCR, maximum DCR you will equate equal to 1. At that DCR equal to 1, you will calculate moment at the other hinge location.
Okay.
And then remaining capacity.
Okay.
And for remaining capacity, you will calculate the additional force it can take. And that additional force you will add to QY1. That will give us QY2. So after this QY1, our structure will be and how much is the balance capacity remaining here? So now you have to solve this to get this Q2. and Q by 2 you will get from here, and then Q by 2 is Q by 1 plus Q by 2. The superscript 2 is representing second iteration or second step. Right. So, you can do that. I can do that. I have done that just so that people don't get confused. Otherwise, you can use any notation. You can continue with same notation, but write that now I am doing second iteration or second step. Everybody agrees that this is alpha by 2?
Yes.
Yes, Pamela? You have got this? MB by 2? Yeah, why not? The previous one? I mean, you are struggling with this.
No, I have done it.
We will discuss that, but first I want you to do that. At the moment you focus on this. Okay? You focus on this and tell me how you have got this.
I have some questions like sharing of this queue. When we share this one, we use this one. Of same EI.
Right. Right. And beams are flexible. Beams are flexible. And you want to determine the distribution. Okay. So you consider stiffness of this, stiffness of this, and so how much is the stiffness of this? Q delta. Q by delta is the stiffness. So this Q divided by delta, you take E this side, that will become the stiffness. Okay, and in this stiffness you see, here it is, it's not symmetric, asymmetric. If it was symmetric, okay, then you have derived this. So for the central column, the stiffness will be approximately double. Okay, it will not be exactly double, but you can calculate the stiffness of this separately, the stiffness of this separately, the stiffness of this separately, and then you can distribute. In fact, when we have added in parallel, we have done that only. So we have divided the total force into these in terms of their stiffness, or we have added the forces. So we will discuss it. At the moment I want you to focus on this. We will talk about it. I will explain. I want others also to listen.
Sir.
Then I will ask all the doubts. But when we are doing this, you are thinking about something else, and when I will be doing that, you will be thinking about this.
Here how difficult it will go like this, but there is any form.
Right.
It could not take movement,
Right.
it could not bend.
Right.
So how we could like straight line?
So what will be the deflected shift? That's the question. Now, once the hinge has formed here, so my column is going to deform like this. So the beam here will deform like this. What will happen to the beam right side? this will remain straight.
No need to satisfy that tangent and joint is perpendicular to that condition.
It is satisfied. If you see the tangent here is this, the tangent here is this, and this angle is what? This angle is theta p.
No, it should be 90 now.
Hmm?
Angle between tangents. It should be 90.
Angle between, sorry, just wait. Angle between which tangents? The tangent to the column and tangent to the beam.
Now
Should be
tangent to
90
the
degrees.
beam, this side is horizontal.
Just a minute. So this angle you see, it is 90 degrees. But because the beam has developed a hinge, at that hinge, beam will not remain straight. The two portions of the beam can rotate. But if you look at the joint here, at the joint it is still 90 degrees.
Not this side means this is not 90 degrees. Sir.
It is. Let me enlarge this. I have enlarged this. Hinges forming in the beam slightly away from the face. Okay. LP by 2 from the face. So you can see that here it is 90 degrees and here this
Theta
is theta. So compatibility is satisfied here also.
This deformation is under only due to increment.
Right.
Under total load, the beam in which plastic beam is formed, it will translate as it is under by the deformation.
Right. So this is this deformed shape I have plotted is incremental deformation. In this you add already deformed shape. That will be the final deformation.
When we change forms, we are unable to loading more, then the reaction on this face will not increase.
No.
It will remain constant.
Right.
And here it will start increasing.
Here. So it is as good as solving this problem. It is like solving this problem.
सर हिंज बीम में फॉर्म हुआ है ना हिंज जो फॉर्म हुआ है
Previous
हाँ
base
previous
was there.
hinge is forming in beam but you are considering that support is not taking reaction.
Sorry?
Support is not taking reaction. You are considering this.
It will not take any additional reaction. Whatever reaction it has taken in the first step, that reaction will be there. But in the second step, when we are performing incremental analysis, for the incremental load, under that condition it will not take any more reaction. Because it is released here. So once it is released, it can't take any force.
Will be mechanism.
Sorry?
Will it be mechanism?
Which will be mechanism?
You have drawn the equivalent diagram for
It is not mechanism. Why you think it will be mechanism?
Q of 2 will act. This simply roll down.
No. It can't roll down. So you can see from here there is a moment. This moment will balance. So it is like this. This is your column. Here is a beam. If this beam was free to rotate, it was mechanism. But what I have done, I have pulled that beam down. Okay. So it will not become a mechanism.
सर यहाँ पे हीन करने की वजह से
हाँ।
यहाँ पे मोमेंट ट्रांसफर नहीं हो रहा है,
Right.
इसकी वजह से यहाँ पे फोर्स भी नहीं आ रहा है।
नहीं आया। This structure should move. Okay. So, what Anirudh is suggesting is okay. So, it should remain like this, and it will move like this. That's what you are suggesting. Any problem in this? It can't happen. It is violating one of our three principles. Which one? Compatibility. So that's why this is not possible. Okay, so you can complete it. Please complete it. And if you are not able to do it, having any difficulty, discuss with me. But I want to take up one question which family has asked, and perhaps you were also saying that. I want that all of you to understand. While doing this problem, we have considered this, let us say Q1, this as Q2, and then Q1 and Q2, how we can obtain in proportion to the stiffness. Okay, so if it is 2 EI, then Q2 will be simply double. What will happen in this case? Let me give you an idea. What will be the ratio between Q1 and Q2? Will be same. EI is same.
Q in terms of
Stiffness will be different because the stiffness depends on L cube.
Yes.
Okay. So this will take 8 times the force of this. Okay. Now the question which they are asking is that when the beam is rigid, we can calculate the ratio. Suppose beam is flexible, beam is not rigid. Can we calculate how much force will go in this? The shear force in these 3 columns. Can we do that? Can we calculate? Yes.
Yes,
We
2 by
can
3.
calculate using the same method. Only thing is that now we have to consider the stiffness of these 3 sub-assemblies. Okay, and this assembly we have already calculated Q versus delta. This assembly, let me call it Q1 versus delta 1. We have calculated similarly for the second assembly. Q2 versus delta 2. And third assembly is same as this. Both are same. First and third assembly. Okay. Now, what will be the stiffness? This slope. This is the stiffness. If you recall, here the deformation was coming delta B plus delta C. Okay. And you can see that delta B here, because here is only one beam for given force, the delta B here is going to be double of this, or the stiffness of this due to beam will be double. But column is same. Contribution of column will remain same. Okay. But if at any given force, at any given displacement, if the force here is half, so you can see that the column deformation contribution, because that also depends on beam. How much deformation comes from the column, that depends on how much resistance the beam is providing. So you can see that the stiffness of this is coming out to be double. You can check, you have already done both. Please check that. And that's why whatever shear is there, you remember, you have done equivalent frame method. So we assume that interior columns will be taking 2Q, outer columns will be taking Q. Why? Because here the resistance is coming from one beam, here the resistance is coming from two beams. So roughly we take Q, Q. You can do exact also. You can calculate. How? Calculate exact K1, K2, K3. Then you can distribute the force. And when we have done parallel combination, actually that's what we have done. In parallel combination, what we were doing? We were taking any value of delta here, we were calculating Q1. Any value of delta here, we were taking this and we were adding. So what we are doing? The total force, either we are adding individual forces or the total force we are subdividing into individual forces in such a way that those are proportional to the stiffness, because delta is same. So these forces will be proportional to stiffness. So this parallel combination which we have done, you can think as if we have added the forces, or you can also think in the opposite way, that we have distributed the forces in proportion to the stiffness. So that is the same thing as dividing this. So this and what we have done here is the same. Only thing is that here the beams were rigid, here the beams are flexible. So here also we are actually adding them in parallel. You can calculate separate Q versus delta for these beams and then you can add in parallel. You will get the same answer here. So adding them in parallel or distributing the force in proportion to stiffness is same thing. We are doing it differently. Okay, fine. That was your question or something else?
Sir, in this I have a doubt.
Yeah.
Means to calculate this Q versus delta for different sub-assemblies, we need the distribution of Q initially, because for that
It can be done reverse way also here. You don't distribute. Calculate this as Q1, this as Q2
in terms of variables.
in terms of variable, and calculate Q1 versus delta 1 and Q2 versus delta 2. Suppose this stiffness is double, so what will happen? This will be K. This will be 2K. And you add them. Then also you will get the same answer.
Because suppose this beam has an stiffness of EI, left side.
Column.
Not this beam, beam.
This beam.
This
Ah,
EI.
EI.
And that right beam is having 2 EI.
Okay.
So then the stiffness on the center column will not be the double.
It won't be double. Double will be there only if left side one beam and right side two beams are same. Then only it will be double. If you change the beams themselves, then it is not going to be double. But the principle will be same. Either you add, so both ways you can do it. These problems you can attempt both ways. You calculate Q versus delta of individual components and connect them in parallel series. That will also give you the same thing. Or if you know in advance the stiffness, you can distribute in proportion to the stiffness. Then also you will get the same answer. Because both the actions are same. Distributing in proportion to stiffness is nothing but adding them in parallel. Okay, so we will continue. Now our class will be on Monday. Yeah, so this Monday I will take. Next week I will ask Tajul to stay. So next week all the classes, all the 6 classes I will. Yeah, so we will finish our tutorial 3. Tutorial 3 is almost same, only very small few points are there. That will I will finish in 1 hour. So we will finish our tutorial 3. And as I told, tutorial 1 to 3 will be our part of measurement. Okay, are you finding this useful? Hands-on software class, what Tajul is taking, are you finding this useful? Should we continue that or should we convert that into theory classes? Yes? Huh? What do you want? Computer class or theory class? Theory class, if we convert it, course will finish early. No? Still you will like to go for that?